Welcome to the lesson on Java Reference Types, Part 3. We'll talk about copying objects using the clone method in this lesson. If you recall, in Part 2, we talked about variables that attach to objects and detach from objects. We also talked about the string classes equals method and the equals equals equality operator. If you haven't seen Parts 1 and 2 of Java Reference Types, I recommend that you do that first. Let's go ahead and demonstrate the concept of copying in Java by using some classes. The first class is called Major and has a name property of type string, has a constructor that passes in a name type of type string, and assigns it to the class's property. Notice how in these two other classes, Student Deep and Student Shallow, we have Major listed as a reference type here at line 8 and here at line 8 as well, Student Shallow. There are two types of cloning or copying that typically occurs in Java, deep copy or shallow copy. The shallow copy makes a true copy of the primitive types from the original class but doesn't detach the reference types from pointing to their original objects. On the other hand, a deep copy does the same thing for primitive types but makes a separate and totally new object with the same values for reference types. However, you have to be careful and make sure you accommodate for all references being detached. Notice also there is a string type listed here at line 9 for Student Shallow and line 9 here for Student Deep. Strings, although being a reference type, acts as a primitive type when it comes to copying due to their immutable features when passing by reference. Further, also notice how you have to implement the clonable interface and override the clone method. The implementation of the clone method here in Student Shallow calls the parents clone method from the object class. In Student Deep, you also see the implements clonable interface along with the override of the clone method. However, notice the difference here in line 21. We create a totally new and separate object called Student Deep and assign it over to the Student Deep variable here by passing in the values from the original object. Let's go ahead and show how shallow copy and deep copy occur. So we have a variable called SS1 and we create a new Student Shallow object by passing in a name and a major. Let's go ahead and create a second Student Shallow variable. That's going to be the copy of the first one. And let's go ahead and display the output of these two objects. And notice here they're both the same. Let's go ahead and make a change to the original object. And display the output of the two objects. So notice here at the third line we have Tom in chemistry, which is the changed original object. But notice here at the fourth line of output, we have the original name, which didn't get changed, which is correct under a shallow copy. However, the major name was changed, which is also correct if you're using a shallow copy, because remember, reference types do not detach from the original object themselves. Now, if you want to make that change as well, you would have to do a deep copy. So let's go ahead and demonstrate the concept of deep copy. We'll create a variable called SD1 of type Student Deep. assign a brand new object of student beep, passing in a name and the major. Let's go ahead and create the copied variable and call the clone method on the original object and assign it to the second object. Let's go ahead and do the same and display the output for SD1 and SD2. Let's comment out the other output statements above just for clarity's sake. So as expected, we see Doug English again. So that works fine. Let's go ahead and make a change to the original object, sd1.name equals Tom, sd1.major.name equals chemistry, and go ahead and display the output again of the two objects. And notice how output statements 3 and 4, our output lines 3 and 4, we have at the third one we have Tom in chemistry, which of course is correct from lines 29 and 30. However, notice the fourth output line, Doug in English, maintained its original values because when the clone method was invoked for a deep copy, if you recall, we create a totally separate object with the original values in them, and so we didn't experience or notice a change when the original object's reference type was changed, as you can see here. This concludes our lesson on Java reference types, part 3.